Thank you to Mr. Jeff Bean for your fascinating presentation. We look forward to what else you have to say during the panel. Our next speaker is Ms. Diyi Yang, an assistant professor in computer science at Stanford University. Professor Yang's research interests are computational social science and natural language processing. Her research goal is to understand the social aspects of language and then build socially aware NLP systems to better support human-to-human as well as human-to-computer interactions. She is a recipient of Forbes 30 Under 30 in Science, i.e. AI 10 to Watch, the Intel Rising Star Faculty Award, as well as the Microsoft Research Facility Faculty Fellowship and NSF Career Award. Please welcome her to the stage.
Hello, everyone. I'm Diyi Yang, an assistant professor at Stanford CS. First, it's a great honor to speak here, also my first time in Vietnam. Second, it's also a great honor to speak after Jeff. I think Jeff has shared a lot of exciting advances in machine learning and also large language models. I want to switch a little bit to talk about more human-facing issues and possibilities that we have today. So my talk today will be around building human-centered large language models. So this is what we have today. A lot of people in my field has been focusing on building the better, and faster large language models, where we focus on a lot of technical challenges around performance, benchmark, and efficiency. On the other side, I think AI creates so much possibilities to enable real-world applications. As a result, people is a very important keyword in this ecosystem. There are a lot of issues related to culture, trust, interaction that we need to be aware of. Otherwise, you will see a lot of the issues that the society faces today, ranging from biases to deepfake to a lot of the low-resource languages here. I want to start with a very interesting query that we played around earlier this year. So many of us have used the chat assistant. So we ask a very interesting question, just like how we are asking each other. Where are you from? This is a very benign query, very neutral. And we force the AI assistant to answer with, I am from country X. Then what we can do is that you can look at how the internal reward model gives specific reward to different answers here. And this is what you would end up with. If you are familiar with this Earth map, then you see that people or the response towards US, Canada actually receive relative higher reward. And then certain countries, especially in Middle East, Africa, Asia, actually receive relative lower reward. So this is what we have today. On the other side, my students also explored a very interesting perspective in terms of safety issues in large language models, where we use persuasion strategies, which is very common in marketing and advertisement, to test those AI assistants. And this includes the very famous grandma example where you jailbreak AI by giving it a very different persuasive request. And then the heat map you are seeing are the success rate in terms of how we actually break OpenAI models in terms of different diverse safety-related queries. On the other side, behind the impressive performance we have, we also saw that there are a lot of issues related to where does the intelligence come from. Is it mainly an issue of data contamination, or the models actually memorize a lot of information? So one of the earlier examples is that people found that in terms of coding examples, such as this specific instance from Codeforce, GPT-4 actually memorized it before its training cutoff dates. So this is also quite interesting for us to reflect on whether the numbers we have on academic benchmark really can translate well to real-world uses. So some of my earlier work, we actually look at what if you could represent a problem into some latent reasoning graph. And then you can see that as we perturb the graph complexity, how the model performance actually change. So this is on one of the widely used math reasoning tasks. As we can see that if you change the reasoning graph complexity, the performance actually drops significantly. On the other side, we also noticed that in terms of models, especially open source ones, bigger models tend to memorize more, and even when they see those sequences only a few times. So this is actually a quite important issue to think about where or in what ways models memorize. Going back to the two keywords I want to mention today, large language model and people. I think a lot of the efforts we have been working on is to think about how to make those large language models actually work for humans. I want to give two quick highlights today. The first one is around how we actually adapt models to low-resource dialects. And second, I want to talk about how we can actually use large language models to help people learn social skills. The first one is about low-resource dialects. Speaking of dialects, many of us are quite familiar with it. Even if we think about English as a language, which often get acclaimed as soft. This is a map of the global speakers who speak English. As you can see, it's actually quite diverse. A lot of the work, at least in academic, what we have been doing is to test those language technologies with what we call standard American English. And what you see is that there will be a lot of disparities and biases that people report, observe, and experience in their daily interactions, as you can read from those news articles. Or if you think about English not being your first language, there is a difference in terms of word error rate for most of the ASR systems that we talk about. More recently, we were thinking about why can't we just ask people about their experience? In fact, when we ask users about how technology failed them, a lot of people report that there are a lot of issues related to speech technology, written technology, and such issues are actually more important or more critical for dialect speakers. So the question here is that we have a lot of impressive large language models, why they are still not there yet, why they are not good enough. Some of the issues related to pre-training filtering, some of them related to multitask learning. There is also issues related to subword tokenization across languages that produce different amount of tokens that's related to different inference cost and performance. So the effort we have been thinking about is how can we actually build tools for underserved communities and their language. To give you some more numbers or evidence for this, this is an earlier visualization of how large language models actually understand the dialect lexicons. So this is only lexicons, more like slangs, terms. Specifically, we look at Indian English. And as you can see, across different wide range of models, we saw that the gap on the top of those boxes are still there for recognizing even just terms in the everyday interaction. Not only with terms, in natural language processing, we also care about grammar or syntax. This is a page where if you give two different sentences to models and ask them, is this part of Indian English? Is this part of Black English, etc.? And we observe a huge difference in terms of whether a specific syntax is recognizable by models. Over the last few years, my team has been thinking about how we can actually make large language models work for those low-resource dialects. And one effort we have been focusing on is called the multi-value, which is a framework for cross-dialectal English NLP. And we focus more than 50 English dialects. Some of them you see on the screen is around the African American vernacular English, Chicano English, Indian English, Appalachian, and the Singapore English. So the very immediate thought is our models doing well with this kind of dialects, and they share a lot of English lexicons. Very interestingly, if we just take a specific data set, like conversational question answering, and you look at how well models are doing when we only change the query from a specific English into the specific dialects. So here is what we can observe. There is a huge performance drop from Standard American English to Chicano English to Indian English, and the most challenging one is actually Singapore English here. Very interesting performance contrast in terms of whether those systems actually work when we have people who are not the mainstream data producers in the current model development. A lot of the efforts is around how we can actually perform efficient adaptation of large language models to low-resource dialects. Several years ago, we have been exploring how parameter-efficient fine-tuning can actually be introduced into this space, because in most domains, we have very limited dialect data. So how can we actually adapt those models to work for those specific dialects? You can do a lot of dialect adapters. You can even use linguistic knowledge to inspire the design and make it very compositional. The very good news is that even with 0.04% of tunable parameters, you can actually increase the performance a lot from what we observed earlier to what we have with some level of specific fine-tuning. So this is quite exciting to look at. However, on the other side, as we probably notice, tech failures come from not only just text, written part, but also from the speech part. One of the earlier studies, not from my group, but from other teams, shows that when they give this kind of speech technologies to a group of older adults who use those kind of systems at home, a lot of them report issues related to their dialects or language being not understood, such as technology wasn't designed to pick up my accent and slang, or technology didn't understand me or my speech patterns. So we saw that despite a great performance on academic benchmark, when it comes to the real world, a lot of issues can arise. So one of the recent efforts we have been focusing on is how we can actually produce smaller and open source voice assistant models that can actually deal with these very diverse situations related to people having accent or having different speech patterns. So this is actually a distilled model where we leverage both Llama 3 and the Whisper. So the key idea here is that how we can actually enforce consistency in terms of next token prediction, not only just predict the next text token, but also audio token. And then through this kind of distillation, you can actually preserve a lot of the social phonetic information and also leverage the impressive capabilities of the text language model. We have a lot of interesting results. One thing I want to mention is that the model called Diva actually performs much better compared to existing open source models on spoken dialect benchmarks. What you can see is that the orange bar is our Diva, which is 8 billion parameter models. And then the Q1 and the Salmon are two state-of-the-art models. So compared to those, we saw that the Diva actually works pretty well, no matter whether it's English spoken in United States, in United Kingdom, in South India, or in Nigeria or other regions. So we all observe great improvement. And this is also true for efforts around machine translation and also social speech, emotion recognition. A lot of the efforts I mentioned actually is on the website, so you can actually go to value-nlp.github.io, or you can install the package to play around with different dialects to see how a specific language can actually be turned or translated into their corresponding dialect version. With that, I want to share you something very exciting that personally I'm very excited about around the social skill training. That is, how can we actually help people pick up social skills through large language model-based agents? So the question here is always, why don't we teach people math? Why don't we teach people coding or physics? I would argue that learning soft skills is actually often out of reach for most people. Either it's time-consuming, expensive, limited in availability, psychologically unsafe. And also people or certain groups, if they don't have enough social capital or network, it's actually really hard to learn specialized social skills. We think that large language model can actually enable interactive, personalized training and learning that can actually transform learning in many, many unthinkable ways. So how could we achieve this? This is a recent framework we introduced called APAM, AI Partner and AI Mentor. AI Partner here is a large language model empowered agent who users can actually practice with on different topics. AI Mentor is a large language model empowered agent who can provide a feedback or a coach to help people improve their skills. Let's say if you want to learn a soft skill called conflict resolution, how to have a difficult conversation with your boss, with your friend, or with your colleague. You can practice with an AI partner here. And then the entire process is going to be coached by an AI mentor. This framework is actually very interesting. So we have been exploring this kind of skill training on a wider range of domains. So think about in therapy. We can actually train novel therapists to let them practice with AI patients and coached by an AI mentor. In terms of conflict resolution, we could have every of us or managers practice with a simulated partner or a colleague, and then coached by conflict resolution experts. You can use this to help teachers better interacting with students. You can even teach students how to negotiate in terms of their job offers, in terms of their workplace management. This is a very exciting framework. I want to use one example to share with you how we think about this and how we actually turn it into something that the people could actually benefit from. For many of you, if you don't know this kind of mental health domain, actually there has been severe and worsening mental health workforce shortage because a lot of people actually suffer from mental health issues. And if you look at how they train counselors today, the effective training is actually very costly, and the traditional approach, such as role play, doesn't scale very well. So we were thinking about other ways of how machine learning or AI can actually help here to train counselors. Think about a very naive conversation on my screen right now. This is a mock conversation. So you have Jane, who is a seeker with mental health concerns. You have Alex, who is a new counselor. When Alex talked to Jane, he could simply say something of, sounds really bad, for a query of, I'm so stressed, it's overwhelming. This is what most of us would respond. Our AI mentor is going to give feedback. It will diagnose which skill to use, provide suggestions, and highlight example response. With all of those facilitating assistance, Alex is going to revise his response into, sounds like you are going through a challenging time. Can you tell me more? And now think about, instead of specific Jane, we actually have many, many different versions of the AI patients here, so that Alex can actually learn in a very customized and personalized fashion to practice a lot of challenging situations that he may encounter in his real counseling sessions. So this is a very nice vision to think about. A lot of technical challenges around how you can actually enable training. I want to mention two of them. The first one is that large language model simulations produce caricature or biased simulations. How can we deal with that? How can we ensure that the simulated persona actually produce consistent demonstration there? This is the issue of how to simulate an AI partner. On the other side, there are also a lot of unfaithful or hallucination feedback given by AI mentor. How should we deal with that? So only two critical issues that I'm going to share today. In terms of how to build the AI partner here, we are thinking about this very human-centered approach called co-design. So we basically co-design with domain experts to set up a constitutional AI fashion. That is, for any kind of conversations the person has with this AI patient, the expert is going to criticize it. This is a human criticize. And then our system is going to induct a set of principles and use it to update the constitutional AI framework set in the backend. So through this way, we actually can create very realistic patients for Alex to practice with. In terms of the consistency issues, we could provide demonstrations if these therapists want to practice with certain type of styles. We actually introduced this system called Ditto, where we provide a few demonstrations and then use imitation learning to flesh out a lot of implicit comparison pairs. That is, a later iteration is better than the previous iteration, and the later iteration is not as good as the ground truth demonstrations. Through this, we can actually create a lot of synthetic data to ensure consistency in the actual generation. In terms of the AI mentor part, we work with domain experts who are senior supervisors to novice counselors and get their help to annotate the data. We also introduce this self-improvement framework so that we can actually conduct further alignment through preference tuning over those synthetic preference pairs we can acquire through this kind of self-improvement framework. There are a lot of technical evaluations. I'm not going to mention those. One thing we did is we actually recruited 15 therapists to use this in their daily workflow. And we found that if you log their interactions, they actually use it quite often. And they sometimes use it directly without editing the response. They also tend to send longer messages with the system we built. If you ask what's good about this kind of AI mentor and what they don't like, the like side is around the system remind them of strategies, inspire responses, increase their confidence, and save time. On the other side, it disrupts the thinking, limit response, and also require decisions to read those, and also take time to read. Right now, we are actually in a large-scale deployment where several psychotherapy courses actually adopt the framework, and we have PhD students in psychotherapy trying out using this kind of framework to learn. They learn with an AI patient, coached by an AI mentor. So this is a great framework to help novice counselors to learn, especially in the earlier stage of their career. The other example I want to just show you is actually how we build this for conflict resolution. This is a system called rehearsal. Basically, what we did is that we simulate very realistic conflicts. And then through this process, we allow people to explore counterfactuals. We teach conflict resolution through this kind of deliberative practice. So people learn basically in a way that there is an AI partner, there is an AI coach. Sometimes they can also set up multiple AI partners to learn. We recruit people and also give them training with an existing conflict resolution course at Stanford Business School. In addition to that, we divided the people into two groups. One group use the system, and another group do not use the system. And in the end, if you observe their performance in some kind of test in the end, we found that people who practice with rehearsal actually have more use of cooperative strategies in general. And people who haven't practiced with rehearsal actually use more aggressive and competitive strategies than the control condition. This is also under deployment to help high schoolers practice their soft skills in school. So some of the reflections I want to point out in terms of what are some of the issues we need to think about. One thing I realized is compared to a lot of the NLP systems that we have been building, putting together a working human-AI interaction systems is quite a non-trivial. There are a lot of steps involved. And this kind of motivates us to think about how you can actually achieve end-to-end workflow optimization. Rather than solving each specific issues at each step, would such an end-to-end workflow be possible? The other thing related to the earlier data contamination and also evaluation on benchmarks is to think about how we can actually really make evaluation useful, and what does that mean? This goes back to a lot of the debate around the benchmarks and also real-world uses in terms of how we can basically put a useful label for a lot of the systems we are building. This is what I want to share today. So basically, how to actually create more human-facing technologies and a lot of the related issues around the culture, social factors. We use low-resource dialects and also how to help people with social skill training as two examples. I think this is a very exciting stage to think about how we can actually make something happen. And I want to remind people that while we are building a lot of the advances for the technical side of large language models, a lot of the issue around the safety, human-computer interaction, trust, and how those systems may even influence society and create some unintended impact remains important and challenging. This is what I want to share. Thank you for listening.